let's talk about Angular. Recently, I was kind of bored at home. I was like, yeah, I should ask a question to community. I was like, what is your least favorite API? Can some of you answer the question? What's your least favorite API inside Angular? What else? Reactive forms, yeah. The CVA. Yeah, the number one answer I got on Reddit on the question was the CVA, so the control value access. So that's an interface you implement when you want to create components that are compatible with the reactive forms. So yeah, people usually have to write forms, but they clearly don't like it. It's the kind of API that you fight against more than you use it. So it wasn't really funny to write forms. So this is why my talk today is about, yeah, forms that you finally will like to write by using the new Signal Forms API. So like Michael introduced me, I'm Matthieu Riegler. I'm a software engineer. I come from France, in the Alps, the other side of the Alps. So yeah, I like to code on the train. I'm always, a lot on the road, posting pictures of me writing codes anywhere. Like when I went to Angular Connect, I made sure to submit API while being under the channel, in the tunnel. So yeah, like he said, I'm part of the team. I work for Google as a contractor, and you can find me on different social networks, Twitter, X, Blue Sky, LinkedIn, etc. So, talking about Signal Forms and Signal in particular. We noticed that our developers love using our new reactivity system. The signals, the computed, the linked signals, etc. So it's great because it allowed you to have an easy to use API to write your applications. You don't have to call all these APIs like Macfog check or things like this to trigger change detection. Everything feels like magic that just works. And also with the signals, we brought in some beautiful compatibility. The computing helps you derive the states. You don't have to have imperative programming anymore. And we went even a bit further last year by introducing the resource API, which allows you to have an asynchronous derivation. And then with forms, we want to challenge our idea of the reactivity systems. And forms and Signal are kind of a match in heaven. And with this, we were able to, like I said, challenge and see if what we went with actually worked and allowed us to develop, like I said, an API that serves you more, that serves you more instead of fighting against it. One of the key idea that we have by doing the Signal form was like, we wanted to answer one of the biggest questions Angular developer had is, which forms API should I use? Usually when I talk about forms, half of the audience is like, yeah, template-driven forms is the best. The other one is like, reactive forms are the best. Well, we want to give you a single answer saying, okay, today you only have, or maybe in the very near future, you have a single answer to that question. One API is better than having two. And by doing this, we wanted also to go in the direction of having, let's say, we wanted to use the best part of the template-driven forms. The fact that it was declarative in the templates, and we wanted also to use the best parts of the reactive forms, the fact that it's more composable. And of course, we added editable signals, and that made our will make our developers happy. So when we went with the idea of building a new forms API, we set ourselves a lot of design goals. So a lot of ideas. First, wanted something that scales well, starting from very simple forms API, a few fields, all the way to multi-step, multi-page forms. We wanted the Signal forms to fit everything. We wanted things that work we wanted it to synchronize effortlessly. the fact that the forms will sync automatically. You don't have to call anything, and it will sync with the data model that's underlying. And of course, we wanted it to rely on and to leverage the reactivity system, like using signals, being able to derive the data, and to do some computation, etc. And of course, using some external states that is not part of the signal of the forms itself. Also, we wanted to make sure that the signal forms it fit well with a rich ecosystem that already exists. For example, you know that some APIs like schema validations that are used across frameworks and across web technologies, front end and back end, that have been already battle tested. We wanted our signal forms to be compatible with it. When I think about such libraries like Zod, like Valibot, which do some kind of schema validation. And of course, something that was really a problem with our existing forms is that we wanted it to allow you to compose freely, that you are able to build composable, reusable, and testable components for your applications. And of course, we wanted it also to integrate effortlessly with the existing form, so that you have some kind of smooth transition story from the existing forms that you have to the future of the forms that you want to use. Those were the main ideas, but of course there was a lot of others. We wanted it to be model driven, so the data is on one part and the form definition is on a part. We wanted it to have way less boilerplate. Remember, like I said, CVA is one of the worst API that we have. A lot of boilerplate, we can make things way simpler. Of course, no more CVA. It should be in the air, or AI should help you more than be a problem with you. So we want to have an API that is friendly to use, where you can just ask your favorite agent to write the forms for you. So we should be able to provide the information that helps the AI, the agent, create the code for you. Too small what I have here. So it should be type safe. So initially, when we wrote the signal forms, there was no type safety into it. Today, we're able to leverage a language TypeScript that is way more powerful than it was 8 or 10 years ago when we wrote the first Angular forms. So today, we want it to have as much type safety as possible. We want it to be declarative, so having less code, less glue code, and should be just easy to write, because you know that the code is more read than written, so it should be for you easy to write, so you can have a better experience when maintaining your code. And of course, accessibility. I know if he's here, yes, of course. Accessibility in mind, so you have less work to do just to handle that. So those were all the ideas that we had, and of course, we want all those ideas packed into our signal forms. And as you might know, they have already been released as experimental, and this is something that's very important to us. So we release it today in V21, so the version that we released in November, as experimental. It means two things for us. So experimental means that is something that we are actively working on. We are developing and shipping fixes and features every week on every patch release, but also it means that we want feedback from you. It's not stable, we will break it, we are breaking it in the past, renaming things, etc., changing some slight behaviors. So it's experimental, it allows you to do some changes outside of our public APIs policy. And it's really important that you try it and give us some feedback. Now, let me present you a bit the API, how it looks like. Like I said, we are model driven. We start with our signal. So the signal just gives you your data. For example, a small feedback form where you have a name, an email, and some feedback text. With this, you have it imagined in a component, and then you just pass that signal into a function called forms, and you create much better. So I don't know why. Let's do it this way. So like I said, we start with a component, we have our model, and we pass that model to the form function, and we create our form object. It will represent what we will use across our different components and the forms that we create. That form function will give you access to a lot of information. Things like what we call a field tree, so a structural access to the value. If you want to access some kind of states, states are the other side. Okay. Yeah, so you can access the state of it. You can access, like I said, when you are in the state, you can access different part of the state, so the value, the validity, different metadata of the form itself. So this is let's say the TypeScript part. If you want to use it in a template, you have your component that will use a single directive. The whole Signal forms today is based on a single directive that you will import in your component. This is the field directive, you add it as an import, and basically you just reference, for example, an input, and you pass it the form and the different fields that you want. Here, I have my small feedback form. I give it a name, the email, just by accessing, the property. Now, of course, forms is just not input and events that get sent. We want to have some logic and some validation to it. So we come back to the TypeScript file. We have that form function where we pass in the model, and we give it a second argument, which is a callback function that will have all our rules. You can access the element of the form. Like I said, you can access the email, the name, but you won't be able to access the value directly. What you will do is you will pass the information so that the function can be called and inferred at the right time. So let's add some rule to our form. We start with the model, like I said, and in it we had the name, the email, and the feedback, and you want to say, okay, I want that email to be required. So I just pass in a built-in validator, which is required, and just give access to the path of it, saying, okay, from the path, give me the email, and automatically the email would be required. Imagine you want to add a second validator, which will check if the email is actually a valid email. Same thing here, where you pass email the same way. And if you want to add custom error messages, you can pass it directly into the form definition. So you don't have to have separate behavior for your forms. The messages are directly into the definition and of the rules, the definition of your Signal forms. Right now, we are shipping 7 different built-in validators: minimum, maximum, email, max length, min length, required, and pattern. So those are the same validators that already exist if you are writing pure HTML. But of course, they're not enough, and you might want to write your own custom validator. So how do you extend the existing API? How do you write something that fits your actual needs? We go back to our form, to the feedback function, and we call a function called validate, where you still pass the field. And in it, you will give it a second callback function where you will actually implement some kind of logic, where you'll be able to read and access the actual value of the forms. For example, here, I'm able to access the value of the field I'm passing, so for example, the email, and I will go check, does my email end up with @yahoo.com? And if ever it does, we will return an error here, or undefined means like the actual behavior that you have in reactive forms. If you return undefined or null, it's actually no error. And if we want to return a custom error, what we do, we actually pass the function custom error with an error message. So, okay, if I give it a yahoo.com email, I will get a seriously ? Error when you validate the email. And if I look back at whole forms with the previous validators that I have, the built-in ones and the custom ones, and of course you'll be able to extract the whole function to your own function. You don't have to inline everything here. Something that is really hard to implement in reactive forms, something that is, when you write it, I've tried to write it, and when you read it, try to maintain it, it's not easy to read. And with signal forms, we want something but it's way easier, you will see. So we go back to our, we look actually at one of the more simple cases where you want to cross-check multiple fields, like when you have a password and we want to check that the second time the password actually matched the first one. So we still have a model, we pass it to the form, and then we go again, custom function validate, and in it, we'll access the value of the confirmed password. So that's the second password that we entered. And to check it against the first password, we can actually leverage a second function, which is value of. Value of is able to read the value of another field of your form. So in that case, what we'll do is you will check the value of the confirmed password and check the value of the password. So here we have a simple check. We check the values, we compare the values of two different fields. And of course, error message, custom error, if I want to return something, to return the error message when the validation isn't correct. Just in a few lines, I implemented cross-field validations, and it's way easier than it was before. If you want, you can also have this in some other functions where you want to disable a field depending on some other field's value. You can do this the same way. Use disable function. You're checking. If we go back to our feedback forms, you say, okay, for my feedback, I will check that if the rating is below 4, I want that the feedback is actually disabled. So you will get an error message, go fix the ratings first, mate, before you can actually give us a feedback. So again, you are able to do cross-file actions, cross-field actions, define cross-field behaviors between different fields. Very easy to write and, like I said, to read. One of the pain points that we had also was composition. Composition was hard and we didn't have much type safety. So if we implement a form that is basically an address book where you have your contacts, we have me, which is the same model, and as the contact, so basically the same object as is checked. First, it's just an element. The second one is an array. The contact is just first name, last name, email, and you create an object which is basically just a new one. You create your form, you say, okay, my model is just my data, it's me, and address, list of contact that is empty. So when you create a new form, basically you would have that. You create your form object from the model and just check that it's only valid if you have at least one element into the contacts field, and if you don't, you add an error message. If you want to define, when I say composition, you can create your own sub function that will help you check the integrity of your data of your form. You can create what we call a schema, which is basically a set of rules that can be used to check something. So here we say, okay, we have a schema that will allow me to check the validity of my contact model. And here say, okay, whenever I get a contact, I will check if the first message is here, so it's required, and we'll check also that the email is invalid. Both cases, again, you can set a custom error message if you want to. And that function can be used then by using the function apply, and you'd say, okay, from my address book, me, so I'll check myself, and against the contact schema. And we can also do the same thing for every item of the contact list, saying, okay, every contact, so type safety here again, we know that it's typed as a contact, and every element will be checked against the schema with the function apply each. So apply will help allow you to check one item directly, and with apply each you will check every single item of that array against that schema. So with a single function you are able to check different fields, and that is either a unique one or an array of items. And if you add that into your templates, basically look like this, where you have basically here, where you see that the context of your form, you just iterate over it and say, okay, every item of the contact is you pass it to the contact component. So basically, you're really just composing your form by reusing the component and the different element that use the same data structure. If I this up, the add contact function here is a function that would do basically what you would do on any signals. You reach out to the contact object on your form and say, okay, to the value, update it. You have a spread element so that the reference to return, like on signals, you have to return a new reference. So we create a new array and say, okay, to the list that I already have, create a new contact. So by creating a new contact, I will just add a new object and make sure that I return a new reference of my list of contacts. Now that we've seen that we can do some composition in terms of rules, schema, and in terms of in the templates, you might want to write custom components that will show you some advanced behavior for your data. So imagine you want to write a component that just displays the stars for a rating for imagine a movie. How would you write that in Angular code without the signal forms? Basically, it would look like this. You say, okay, I have a ratings. It's just a signal with a value, and if it's disabled, a signal true or false. And you would pass that to the function. Say, okay, you pass the value and pass disable as an input. That's without any forms. That's just basic inputs and signals for your components. If you implement that, you would say, okay, let's make that for the star ratings component. I have a value, which is a model. Model, as you know, is an input and an output. So every time something happens on the model, it will send an event to the parent component. So I got a value. The star is basically what you have here. So you want that the icon is either star outline or star, depending on the value. If it's below the index below the value, you will have the star outline. So it means not the full one. And if it's above the value, you will have the star. So just a simple component that displays the star or not, depending on the rating. Again, there's no signal forms here. We add the function that just updates the value when you click on it. So this is the one that will actually send the event back to the parent. Additional styling, just to write a component like you would without any forms. Basic signals, input, output, as you would write. So this is how you would use it. So the parent has a signal with the value, and the disabled where you pass it down input output. The question is, how would you transform that and say, okay, I want to write to use signal forms to actually work with my component? The custom component I created, the value I'm passing, and the only thing I will have to do is just say, okay, I will actually give it a field instead of passing the value, and just giving it with the creating a form object. So we only had value, we're passing the ratings, and from just a signal that we had, we create a form object and we replace the value with just the field directive. And basically that's just it. It's just as simple. You don't have to implement anything else. There's no CVA, there's no specific API. If you have a value in a component, it will work out of the box with the field directive. And the first time I saw it, I was like mind blown, way much easier. So the magic behind it is actually expressed into an interface that you can implement, and that will describe all the signals that are supported directly by the field directive. So like I said, the value, that's the one that you will want to use because that is the value that represents your model. It should be a model, either a model or an input plus an output that match together. But also you can have a disable input. That's what I also showed, that if you have a disabled input here, you will be able to control the signal forms will be able to set or not the disabled state of your component. You can have disable reason, we'll explain why it is disabled. You can set read only, so now the signal forms will finally support something that have been asked by a lot of developers, being able to set a read only state on elements. You can have the validity of it, dirtiness, etc., etc. So all the fields are declared by the form UI control, and this is where you can say, okay, this is what I want to support for my component. And of course, some metadata, for example, the minimum that is accepted for the component. So this is basically the idea of what you will want to use on the signal forms. And like I said, it is something that is experimental because it is a work in progress. I gave that talk like 2 months ago. I was like, yeah, I can tell you what the work in progress was 2 months ago when we initially released in the pre-release before we shipped V21. We want to do some docs, some ASIC validation. We want to have some debouncing support, having a great interop story. We want to have better template type checking, performance optimizations, dynamic forms, etc., etc., etc. And since then, so in the last few months, we shipped a lot of things. So we shipped the first version of our docs, async validation works, debouncing also works, a two-way interop, I will give you more details after this, and type checking also, let's say, basically works. There are a lot of edge cases that we still need to fix. But basically the idea is that today, signal forms, you could say, could work in like 90% of the cases, and we still need to smooth the edges. Just to give you a bit of example, debounce. So debounce is kind of weird in the sense that debounce, usually you debounce an event, not a value. Signals are not an event stream like observables were. But in the case of forms, the feedback, the schema feedback callback function that we have, not only declares some rules, but also some behaviors for a form. And here we just say, okay, with the debounce function, we can actually declare some kind of behavior, some kind of delay between the value that was input on the component itself, the element, for example, the input, and the real value that is known by the form itself. So if you want just to debounce, say, okay, the street value, I just want you to actually update the model that's behind it, you can do that after 500 milliseconds. And of course, if you want something that is more advanced with imagining some kind of async request with a backend server, you can give it something that returns a promise. So you can debounce, but also, like I said, something very interesting for us because it's part of our DNA, it's that supporting what's already existing, but also providing you a better migration story. So you can just have a smooth migration from the existing forms, either templates or reactive forms, to the new API. So we want a two-way interop saying that, okay, we want the signal forms to work with CVA components. And this is already true since we shipped into V21, the experimental version. You can already use the signal forms with CVA components. For example, all the Angular material components implement the CVA. It can just plug in the signal forms directly to it, and it will just work by passing the field directive onto it. Another one that's really interesting also is that you can use the signal forms with the reactive forms. So having some kind of form control, form group, you pass it to a signal form object. A small example, for the interop, we have a sub-entry on the signal form. So Angular form signal compat, which will allow you to create some forms using reactive form structures. So you still have the field directive, you still have your model, which is based on a signal. But here, as you can see, we don't have the value directly. We use the reactive form structures. A form control, you give it a form control here and another one here. It's not nullable, of course. And from this, you just read the signal you have with the form controls, and you create the form object with a compact form function that comes from the compact subentry. So it's just basic idea to show you that we want to provide something that helps you migrate smoothly to the new forms. If you want to play with it, you can have a look at the signal forms demo on StackBits, stackbits.com/edit/signal forms, or you can try it yourself. Just pull a new project from the CLI, ngNew, and create a new project and try a bit with the new API. So like I said, this is something that we released in V21 last month, and it's still very much experimental, and it's very important to us that you give us feedback, because there's something that we want to do is to promote it to stable whenever it's possible and whenever we feel confident about it. So if you give us feedback, it will give us the confidence that what we have at a point is good enough for us to consider it stable. So if you give us feedback, maybe we'll have it stable in the next few months. Thank you so much. If you have any questions, I'll be around the whole afternoon.